even writing is also very easy and understanding also it's very easy. Okay, so yesterday we have seen this kind of syntax. Now we will see the example. Here my array name is AITM. Here I have taken some elements. I don't know the exact elements. Okay, instead of counting the elements, we just use for each loop, or another one is what? Name. Another for each loop, another name for this loop. There are two types of names, right? For each loop, another one is another name. Enhanced for loop. Enhanced for loop. Okay, so here if we use enhanced for loop, we don't bother about array size. Simply we have to use array name preceded by colon, then preceded by variable name. Here I have taken variable name is MCA, then array name is what? AITM. Int AITM. In which dimension it is? It has only one dimension, right? So one square box, so one dimension. So int MCA colon AITM. Now what will happen? All the AITM contents will sit onto MCA variable. Then you have to print the MCA variable. Then you will get the output like 10, 20, 30 and 40. It's very easiest example and you will get maximum marks. Okay, just to write this line for int MCA then colon AITM. That's it. Okay. Now what is same concept? What is enhanced for loop? Then write a Java program to search an element in an array using enhanced for loop. Here you have to write a simple Java program to perform what? To perform what? Search operation. Simple search. Right. Now all have to observe this logic and it's very easy. Okay. Here my array name is AITM. Now I have declared in different ways. See here, all of you observe. In previous example we have declared using what? New, and like that we have used, right? But here simply I have taken one array name. That's it. You can follow previous step also, or you can, if you are comfortable with this array, you can follow. Okay. And here I am taking another variable name is key. Okay, key has the value 4. Now our job is to search whether 4 is present in this list, array element list. 4 is present or not here? 1, 2, 3, 4. These all are array elements. From these array elements we have to search a particular value, right? To store that value I have taken another variable name, that is key, right? Now how this enhanced for loop will work? Let's see. First I will take this line. I am taking all the array elements from AITM to shift on which variable? MCA. This line, all of you understanding, right? All array elements should be shift on MCA variable. Now I want to match with what? Array elements equal to key element. My key element is what now? 4. And MCA has the values what? 1, 2, 3, 4. Let's see this line, try to understand. Now our key is 4 here, then MCA elements are 1, 2, 3, 4. MCA elements are 1, 2, 3, 4. Now check the condition. MCA value is how much now? 1 equal to 4. Condition is true or false? Here condition true or false? False. Now take another element. What is the next element here? Here we are not using any increment operator. We have to if this is a passion to use enhanced for loop, it starts with from first element and directly ends with last element. Now we have taken the first element, that is first, that is number is 1. So after it is matching, that condition is false. If condition is false, then automatically it will take next element. What is the next element? 2. Now 2 will going to match. 2 equal to 4. Condition true or false? Condition is false. Now again it will take next element. Next element is 3. 3 equal to 4. Condition is false. Then again it will take next element, that is fourth element. Fourth element. Now see, 4 equal to 4. Condition is matching. 4 equal to 4, condition is matching. Yes, if condition is match, then what is our job? Key is found. We have to print a message like that, key is found. So that we have to print in SOP. SOP, key is found. After founding, next job is what? We have to make this break. That is jumping statement, right? Break is a jumping statement. Here no need to execute next task, right? So after our key is found, we have to make terminate for this loop, or that's why we are using break. After key is found, then our job is over, right? Is it understood? Is it clear, right? Okay. Now in this case, now our key element is how much? Now our key element is what? 5. So 5 is present in this array list. 1 2 3 4, only 4 elements are there, so 5 is not present. In this situation also you have to print one message. That message name is what? That message name is what? If you find key, then you are printing key is found. Suppose if you are not getting any keys, or it will not match with array elements, in that situation what message you will print? Key is found. Yeah, simple message. Then you have to print that another statement, key is not found. So it is a simple example they have asked in your previous exam. What is enhanced for loop? Explain and write a Java program to search a particular value. So it's a simple logic, try to understand. Okay. Now we will move on to next concept. Another one. Write a Java program to find sum of array elements. Sum of array elements. What elements you have in array, you have to make it sum. Like 1 2 3 4, you have these array elements. So what is the sum for these array elements? 1 plus 2 how much? 1 plus 2. 3 plus okay, 1 plus 2 plus 3. Now 3 plus 3 how much? 6. 6 plus 4 how much? 10. So you have to calculate in this way. So using enhanced for loop only, you have to write a program. Now see here, AITM values I have taken 1 2 3 4. Then initial, again I am taking one variable because we have to calculate the sum. For that reason we are taking int sum equal to 0 initially. I will tell you why you have to initialize 0. Now observe this red line, int MCA AITM. So what will happen here? From whatever we have taken two variables, right? One is int MCA, another one is array name AITM. Now after executing this for loop, what will happen? Whatever contents are there from AITM, what are the contents? array elements in AITM? 1, 2, 3, 4. 1 to 4. Now what will happen? It will shift onto MCA variable. What array elements have? It will shift onto MCA variable. See, it is shifting from AITM to MCA variable. Shifted, right? Now we have to make the operation what? Sum of array elements. So how to calculate sum of array elements? First you have to add 1 plus 2, then 3, result is 3, again 3 plus 3, result is 6, then 6 plus 4, result is 10. Now you have to print this result, that is answer is 10, right? To perform these 1 plus 2 plus 3 plus 4, you have to use this operation. Sum is equal to sum plus MCA. MCA means what here? MCA has the values, how many values? 1, 2, 3, 4. Then sum, you have to add previous sum. 1 plus 2, that is previous sum, right? So then here you have to perform this operation. All of you observe, here I have taken two variable, one is sum, another one is MCA. Here I am performing addition operation. Then this is for result purpose. Here sum is equal to sum plus MCA. Understood these three boxes? What I have written this line. So now sum is equal to sum plus MCA, right? Now we'll see what will happen. Now what is the sum value here? Initially we need one value. For that purpose we have to assign sum equal to what? 0. Sum initialization with what? 0. Here we have to take this value. Initially sum value is 0 plus, what is the MCA value? Which value I have to take? Shall I take all 1, 2, 3, 4 or shall I take one by one? 1, 2, 3, 4 like that. Yeah, very good. 1. So now 1. 0 plus 1. What is the result? 1. 1 should be stored in where? Sum variable. 1 should be stored in sum variable. Now see, previous sum value is what? 0. After calculating this, now sum value becomes what now? 1. Right? Now apply the same logic. Now again MCA value is what? 2. Now previous sum value is what? 1. Very good. 1. 1 plus 2. So answer is 3. 3 should be stored in sum variable. Now again take another element. Next element is what? 3. Sum previous value is what? 3. 3 plus 3 how much? 6. 6 should be stored in variable sum. Right? Now again take one more, that is the last element, 4. Previous sum value is how much now? 6. 6 plus 4. What is the result? 10. Result is 10. Yeah. Now in MCA, any values are there? All values are over now. So all values are over. So no need to take next element. So our loop will going to terminate in this condition. So what we have final value? That is 10. 10 should be stored in which variable? 10 is sum. Yes, to print the 10 result, so how we have to write? SOP sum is plus which variable I have to write? Sum. So this is a result. SOP sum is equal to, or whatever you can write. Okay, sum, then plus sum. It is important. Plus sum. Variable name followed by this one. Understood this one? Clear? Okay. That's why you have to concentrate all kinds of examples. In with you, they may going to ask different kinds of questions, but concepts are same. But while asking, the questions are different way. Okay. Now, same way, we have seen only for each statement in single dimensional array. but how to apply this for each or for style or enhancer for in multi-dimensional array? Another concept. Okay, a multi-dimensional array consists of arrays of arrays. For example, we can see a two-dimensional array is an array of one-dimensional array. Okay, that is called multi-dimensional array. This is important when iterating over multi-dimensional array. Iterating means what here? Now we have taken one by one elements, right? 1, 2, 3, 4. That is called iterating over multi-dimensional array, because each iteration obtain the next array, not an individual element. Okay? Next array it will consider. Instead of taking individual element, it will take arrays of arrays. We can call multi-dimensional array. So it will take one array, then again it will take another array. So in this way it will work, right? Let's see one example. You better understand this one. Now same way, same syntax you have to apply here. Let me know how many rows and how many columns are there here. How many rows and how many columns in 2D? How many rows and how many columns? Yeah, very good. 2 rows and 3 columns. So for this we have to use 2 for loops, right? 2 rows, 2 columns, we have to use 2 for loops because it is in 2D, because we are using in 2 subscript here. So one for loop, another for loop. But in which for loop we have to use here? Enhanced for loop. In enhanced for loop we have to use only 2 variables. One is integer variable, another one is array name. That's it. Here I am taking, observe first for loop, int array x. I have declared another array here. Int array name, that is x. This is important line. We are using enhanced for loop in a multi-dimensional array. Int square box array name x, right? Then MCA, whatever it is a multi-dimensional array, that's why I told here each iteration obtains the next array. Each iteration obtains the next array, not an individual element. That's why we have to take here array. Another array we have to define in for loop. Then MCA is our original array, MCA, right? Whatever is content are there, it will going to shift on this array name. That array name is what? X. First line is finished. Then again it will take another row or column. So whatever present on the X array, it should be move on to which one? Which variable? Y variable. Whatever present on the X, it should be move on to Y variable, then print the Y. So you will get the output 1, 2, 3, 6, 4, 5. Like that you will get. Understood this concept? Two things you have to remember. First, while using enhanced for loop, then in multi-dimensional array, compulsory you have to define another array here, another array. In previous examples you have taken variable, but here what kind of variable you have to take? Array variable you have to take. That is important. Now shift from original array to this array and take this array to another variable, then we print this variable, that is y. So it will print the all elements like this: 1, 2, 3, 6, 4, 5. This is enhanced for loop using in multi-dimensional array. Understood this concept? Will you able to write this description and this example, or anything feeling difficulty? Over this? Okay. Sujit, understood this? another concept. Explain the following with an example, that is bitwise operator, or it may going to ask any questions they will going to ask like this. Here they have asked bitwise operator. Okay, so let's see on these operators. We have seen some operators in previous classes, right? Then that concepts we have left because those concepts belongs to this model. So that's why we have taken now here bitwise operators. So let's see what are the bitwise operators. And again you are having this question: explain the operations of left shift and right shift operators with an example. This question will also is asked by your VTU. And another one is explain left shift and right shift operators. Here sometimes they may going to ask with an example or without example. So without example you compulsory write with example only. They ask question like this, compulsory have to give one example. Is it clear? So all three types of questions they have asked. Bitwise operators same, left shift and right shift operators comes under bitwise operator. Okay, now let's see bitwise operators. These can be applied to values of type. Bitwise operators can be applied which type of values? Only int, long, short, char or byte. Only we have to take these data types, bitwise operators. And bitwise operations cannot be used on where boolean data type, float data type, double or class types. 2 points you have to write. One is which type you are using to apply bitwise and which type will not support to use bitwise operations. Boolean, float, double, class, it will not going to apply bitwise operations, right? And they are called bitwise operators because they are used to test and set or shift the individual bits that make up a value. That's why we can call these bitwise operators. So why we have to call bitwise? We have to mention this line, then which one data type will support and which will not support the data types, that you have to mention in bitwise operators. After writing this explanation, then you go for what are the bitwise operators. These all are bitwise operators, and or XOR and NOT. Then also you have shift, right shift, left shift. Another one is unsigned shift. I think you may have studied shift, right shift and left shift in C language. So here extra one is unsigned shift, unsigned right shift. Okay, so you have to mention what kind of bitwise operators. After mentioning, you just give one example, right? Let's see. So the difference is that then you have to give this table, take 4 values, 0, this one 0 0 1 1, then 0 1 0 1. First you write these values 0 0 1 1. First you have to write, then next you have to write 0 1 0 1 like this. Okay. And here you have to apply the operations, that is AND, OR, XOR and NOT. AND means what here? Whenever both the operands are true, I mean 1 1. In this case only 1 will present in AND operation. And in XOR operations, whenever both the operands are 0, the result is 0, right? And remaining values are 1 1, because you are having 1 here, here 1, then 1 1. So it is about OR operator. And in XOR, what will happen here? When both the values are 0, the result is 0, and both the values are 1, result is 0. Whatever remaining bits are there, that will present 1 1. It is XOR operation. And NOT means opposite. Two values are 0. It NOT means what will happen? 1. Then two values 1. Opposite to 1, 0. Then two values 0. Opposite to 0. It displayed 1, 1. Then opposite to 1, that is 0. Not P and not Q. Understood this table? Compulsory you have to write this table. If they ask in bitwise operator, explain bitwise operator, you have to write this table compulsory, and previous slide is also important. Then the next one is, if they ask explain in detail bitwise AND, bitwise OR, bitwise XOR, in that situation you have to give simple example. See here, bitwise AND. What will happen? And when both the operands is 0, at that time it will present 0, otherwise it will display 1. Okay, 0 0 here, 0 is present, 1 1 1, 0 1 0, 1 0 0, like this it will present. So if you take this value 10 and 6, after making the AND operation, here we will get the value 2, because all are zeros only, right? So it is about AND operation. Now in OR operator, bitwise OR. Bitwise OR is the 0 when both the bits are 0, otherwise 1. Compulsory, when it will display 0 0, it should be displaying 0 only. Result is 0, because when both the bits, this one is 0, so result is 0. Otherwise in 1 0 or 0 1, in that case you will get the value 1. So 1 1, result is 1, 0 1, result is 1, 1 0, result is 1. So after taking these two values 10 and 6, converted into binary form. See, I have written here 1 2 4 8. This is converting decimal into binary digits. So apply here, based on this, not only 8, it will again move on to 16, then 32, then 64 and 128 and so on. Here I have taken only 4 bits, 1 2 3 4, like that I have taken only 4 bits. Understood this one, how to write bits? Okay, see here, take for example 10 how to 10 how to write here. First you will take 8 in this, here you will write 1, then again if you add 2, then 8 plus 2 is 10, so here you also make it 1. So 1 0 1 0, see, 1 0 1 0, like that you have to take. Then apply the bitwise OR and bitwise AND, right? Then you will get the result. So making this 1 1 1 triple 1, so 8 plus 4 12, 12 plus 2 14, so you will get the answer 14, right? Like this you have to understand. Then the next one is XOR. XOR condition you write, XOR is 1 when if both bits are different, means 0 and 1. In that situation you will get the result 1, otherwise 0. See, 0 0, both the bits are 0, then result is what? 0 only. In both the results 1 1, again you will get the result 0, right? And in this case 0 and 1, see, condition is given 0 and 1, you have the result 1. So 0 and 1, you are getting the result 1. In here 1 and 0, so 1 is present, so result is 1. After taking these 10 and 6 values, applying XOR, then you will get 12. See how 12 you have to calculate, 1 and 1. In 8 number you just put 1 and here is 1. So 8 plus 4, 12. You will get the result 12. So 1 1, remaining 2 bits are 0 0. So simple examples you have to write, right? And Apart from this, you will get one small program, right? Converting lowercase letter into uppercase letter using what? And, bitwise and. Converting lowercase letter into uppercase letter. See, these all are our ASCII values: A, capital A, B, B, C, C, D, D, and so on. Okay, these all are 6-bit binary code and representing in numbers 0, 1, 2, 3, 25, 26, 27, 28. These all are character in ASCII code. Okay, now the program they have mentioned in your syllabus like this: converting lowercase letter into uppercase letter. Here A you are going to display, then converting into uppercase letter, that is capital A, then B capital B, C capital C, D capital D, like this. Okay, here I have taken one for loop, initialization with 0 and less than 10 and increment the I. Now here what I am performing, which type of conversion it is? Can anyone tell me? Here I am using conversion. It looks like conversion, right? So what kind of conversion it? Yeah, character conversion. I mean, in which type conversion? Explicit or implicit? Two types of conversions. One is explicit, another one is implicit. Here we are using explicit conversion because we are using bracket here. See, bracket. Inside bracket we are performing a type. We are mentioning type, that is char. Okay, because I is integer purpose. I is integer value, right? Less than 10 means it is an integer value. Then it will going to convert it into character. That character will store it on where? CH variable. CH is which type? Char type. So that's why we have to take explicit conversion here, right? Now after it will take A values, it will print A. See here, A, then take the I value, then it will going to add 0 plus 1. It will take what? Capital. It will print one capital A. It will print capital A. First it will print A, small a, then it will print capital A, because 0 plus 1. 0 plus 1 means what? 1. What is the 1 here? Code you are using 1. 1 is representing here what? Capital A. That should be displayed here. A and A. Is it clear? Then here this statement we are using to turn off the 6th bit. To turn off the 6th bit, for this purpose we are using this line, right? Then we are printing the capital A here. Is it clear? Converting from lowercase to uppercase using AND. Here I am using AND operator here. CH AND 65503. It is a code to turn off the 6th bit. Here how many bits are there? Count here: 1, 2, 3, 4, 5, 6. To terminate the display next bit, we have to use this code, right? So in exam, if you remember this code, you can write. Otherwise you just skip this line, red line, then directly write this one somehow. Okay, at last moment you can try like this. Then the next example is ulta. Here converting converting uppercase into lowercase with OR operator. Here I am using OR. See, these two lines are same, but here you have to make capital A. Okay, and this line here you are using OR operator to make what? Converting uppercase letter into lowercase letter, right? So these two examples they have mentioned in your syllabus in bitwise operators, and this time they are going to ask this question. Instead of explaining a bitwise operator, they will going to ask what converting uppercase letter into lowercase letter. Like that directly they will going to ask a question. So 2 examples you have to make practice. Apart from writing these bitwise operators XOR, or and, or and not, you have to concentrate on these 2 examples. Now we will see another one, shift operator. We have 3 types of shift operators. One is left shift, another one is right, and another one is unsigned right shift operators. Left shift operators, and here you have to make 2 less than symbols, and right shift operators you have to mention 2 greater than operators or symbols. Then unsigned you have to use 3 greater than symbols. Unsigned you have to use 3 greater than symbols. Okay, that is right shift. Unsigned right shift. Let's see one example for this, and here one syntax is there how to use that shifting operators. First you have to write here value, then use the less than or greater than or unsigned operators. Then here you have to give what number of bits, how much bits you have to shifting. So here if you can shift 2, or you can shift 3, or you can shift in 1. So now in this example I have taken only 1 bit shift. 1 bit shift. See here, left shift operator shifts all bits towards the left by a certain number of specified bits. Certain number of specified bits means, see here I am using the syntax here, number, left shift, how many bit I have to shift? Only 1 bit. This we have to represent. Here you may represent 2 or 3 and so on, but here I am taking the simple example, that is bit shifting by 1 position. Bit shifting by 1 position. Now I have taken number is 5. Then after making this left shift by 1 bit, then I will get the result 10. I will get the result 10. Shifting. Is it clear? Have you understood this shifting technique, or shall I write down this? What to do? Understood, right? Okay. Don't confuse. If you are confusing, I will write and show you how. Yes, how 10 will print. Right? You just write using 1, 2, 4, 8 numbers. Then apply the 5 here. Then you will get what? Here you will write 1. Here 1, 2, oh, not like this. One, 2, 4, 8. What I told? 5, right? Now 5 you can write it here, 4 and 1, right? Remaining is what? 0. Remaining it is 0. Now you make it left shift operator, right? So you have this value, that is 0, 1, 0, 1. Now make it left shift by 1 bit. So here by default you will get here 0. Then 1 is shifted to in this position, and 0 is shifted to here, that is 0, and 1 is shifted to this bit, then here. Now count what is the answer here. 1 is belongs to which bit? 8. Then this one is belongs to which bit? 2. 8 plus 2 how much? 8 plus 2 10. So you will get the 10 when after shifting, left shifting by 1 bit. So in this way you have to understand. Okay, see, now we have got the answer is 10, right? Similarly in right shift, means towards right side you have to shift. So after shifting this one you will get 2. After shifting towards the right side by 1 bit you will get the answer 2. Like similarly we have done, right? So in that example I have taken left shift, then you have to move in right shift, so you will get the answer 2 in right shift operator, right? Then another one, unassigned right shift. Here you have to use 3 symbols, greater than symbols. Then example you are taking 8, then it should give the result 4. Unassigned right shift operator. Unassigned means what here? Positive integer. If you are getting negative integer, then it will, we can call it is what? Signed right shift operator, right? Here we are not using that minus, so whole integer we are using, so that's why we have to call unsigned right shift operator. Is it clear? So these if they ask in main exam, explain shifting operator left, right, then you have to give the definition, then symbol, then give one example, right? Is it have you understood, or any difficulties? You are fine. Okay. Now we will move on to bitwise shorthand assignment. Sometimes what happen, they may going to ask these questions in 4 marks or 5 marks. Okay, explain bitwise shorthand assignment. Similarly we have seen in shorthand assignment operators, right? So here also we can use like this: x is equal to x XOR 127. So it is normally in traditional way we are using this operation, okay, or this expression. If we use bitwise shorthand assignment, then we have to use, 1 minute, my battery is here, no power supply, so